Good morning, everybody. Tomorrow is your test on Chapter 8, logarithms, but you can't do logarithms without exponents. So one of the things that I think you've noticed on this huge review packet, which I wasn't expecting you to print out, by the way, I said do it in your notebook, but I'm going to do the even today. Now, I gave you the odd to do yesterday, and there were a couple of questions that I did write on the answer key to omit because we're going to be doing them in Chapter 15. So you could tell different workbook companies, different textbook companies, sometimes they jumble things up a little bit. So I'm going to do the even problems today. This is your assignment for today, and you should really work along with me. Make sure you understand everything, and please email me questions or concerns. All right, so starting with number 2. Number 2 says f of x is equal to 3 to the x, and g of x is equal to 2x plus 1. All right, so this is an exponential equation, and this is a linear equation, an exponent and a line. And they want you to find f of g of 2. So it's a composition. This is going back f of g of 2. This is going back to chapter 4 when we did that huge thing on functions. So f of g of negative 2. So again, parentheses inner first, we're doing g first. 2 times negative 2 plus 1, and this is going to give us negative 4 plus 1, negative 3. Now we want f of negative 3. So that means 3 to the negative third. Negative exponent, flip 1 over 3 to the third, and you can either work this out with multiplication or use your calculator. 1 over 27. If you just type it in, make sure you hit math, enter, because I'm not taking the decimal as you know. You know you have to give me the fraction. All right, so which of the following equations is graphed below? Well, this guy here, I would tell you, use your calculator. But if I draw it out, you have this. Now, one of the first things you want to notice is you're not going through 0, 1. If you just had regular equation from when we did this back in chapter 7, if you had y equals some base to the negative x, and it had no initial amount, it didn't have an a value, this guy would have gone through the point 0, 1. Because every exponent to the 0 power, regardless, will go through 0, 1. Now this guy is going through 1, 2, 3. This is going through 0, 3. So that's telling you right now, like we said in class, we pushed this guy up by 2. And we also said in class that to be growing in quadrant 2, which is a negative x quadrant, we're a negative x, or this would be y equals 1 over b, take care of that negative exponent to the x. So you look and you say, well, that's happening on choice 2 or choice 4, but now you have that plus 2, where we should have went through here, but now we're going through here, so that means we had to push it up by 2, and that is why we are choice 2. And number 2, what were we? We were choice 1. All right, let's take a look at number 6 now. It says, which of the following set represents all the solutions to 9 to the absolute value of x plus 1 equals 27. All right, well, they're trying to throw you off with the absolute value. However, let's take a moment. 9, if I hand you a 9, remember you would tell me, okay, 3 squared. And then I still have absolute value of x minus 1, plus 1 rather. And then I hand you the 27 and you give me 3 to the third. So now, if we're equal and our bases are equal, our exponents are equal. So that means that 2 times the absolute value of x plus 1 in a parenthesis, because this was times the whole thing, so don't forget the parenthesis, is equal to 3. Now, you could distribute, or you can start with the inverse of multiplication is division, and the absolute value of x plus 1 is now equal to 3 halves, or 1.5, if that makes it a little bit easier for you to see, and then minus 1 from both sides, and the absolute value of x is equal to 0.5. So on your choices, that would be, absolute value could be positive or it could be negative, and 0.5 is 1/2, so this would be choice 4. There's your 1/2 on choice 4. I can only fit 3 problems, it looks like, especially because I write so big, but give me a moment, let me erase, and we'll pick up from number 8. So again, number 6 rather. So if you are having trouble, make sure, no, that was 6. Make sure that you are stopping this video and you're watching things more closely. And make sure you're going through all your lessons, even go back over all the videos. There's a video for all these lessons too, and that will help you. Maybe pick up something you missed the first time around. All right, number 8, a colony of bunnies is growing at a rate of 5% per month. Okay, so you're growing. So your rate is growing 5%, and your time is months. And I know it's months, it's not compounding monthly. I know it's months because they just said months. They would literally have to say compound in order to use the formula that has the fraction in it. Okay, if the colony started with an initial population of 20 bunnies, so there's my initial population of 20 bunnies, which of the following is closest to the number of months it will take for the population to double? All right, so now I want the amount over time to be 40, 20 times 2. So here, using the equation, amount over time is equal to the initial amount, 1 plus the rate to the time. Because we're growing, it's the plus, not the minus. So I have 20 bunnies is equal, 40 bunnies. 40 bunnies is equal to 20 bunnies, and then I have 1.05 to the time, which is months. And remember, 5% decimal moves twice, so it's here 12.05. Divide by 20, and here's where you get your double. And we talked about how the parameter of the problem shows up, which is helpful. And now I'll use my natural log of 2, and I'll have t times the natural log of 1.05. Divide now by the natural log of 1.05. And let's see how many months I get when I type this in on my calculator. And I get 14.206, and it's going on, but they told me to the month. So from 14, I'm looking at the 2, and I get 14 months. Not a lot of time, a year and 2 months, and I have 20 bunnies running around my backyard. That would be crazy. All right, a quickly decaying radioactive substance loses 12% of its radioactive mass each hour. So now my rate is going down 12%. And this is per hour. So that is giving me my time in terms of hours now, just like this was months. They didn't say compounding. They didn't say every 5 hours. They said per hour. So if they would have said compound, or if they would have said it took like a certain number of hours to lose a half, then you would have that fraction on the exponent. No fraction on the exponent. All right, so if the sample originally contains 500 grams, after how many hours to the nearest hour, so we're rounding to the nearest whole number, how long will it have 50 grams? So, okay, so the initial mass is 500, and how long until it's 50? So it's always helpful to write this out the same way I do in class, because that's going to really get you everything you need to know. So same formula, because there was no compounding, and you'll notice this is probably the formula that I'm going to ask you to use on the test, especially for these word problems. So now I have the amount over time, unless I ask you a compound continuously, and that would be the PERT formula with the E, because we did 2 days with the number E. Back to this one. Amount over time is 50, initial 500, and then I have 1 minus 12% to the time, which is hours. Now 1 whole minus 12% is 0.88. But I have to divide by 500, and this now gives me 50 divided by 500 is 0.1, 0.1. So again, let's throw some logs on. Natural log of 0.1 is equal to t, natural log of 0.88. And I'm going to divide by the natural log of 0.88. Now guys, again, I told you, you can use any log. You can use the common log. But I just like the natural log because it's the one that you use with the money problems. And that's the one you're going to use the most in life. That's the one that's the most important to you. So I just like the natural log. But again, feel free to use the common log on these questions. When you have a question with E in it, Euler's number, the PERT formula, you have to use natural log. So this would be the natural log of 0.1 divided by the natural log of 0.88. And this gives me 18.02, and they wanted me to round, so this would be 18 hours. And this is going to be choice 4. This was choice 4. And this is, again, problem 10. I really have to start labeling a little bit better. And problem 8, our answer was choice 2. There we go. So 8 and 10. Hopefully you're doing these and it's like clicking now. You're nodding your head right along with me with the work, and you know, life is going pretty good. So here, number 12, we have another composition of functions. So we started with the composition, and I told you in the beginning of the year when we did chapter 4, it's one of those chapters that's like never ending. And it's really not. Every chapter we've done since chapter 4, we've had to go back and use that work with the compositions, with the domain, with the range, and all that other good stuff. So h of x on 12, h of x is equal to 1 over x squared plus 2. Whoa, make that fraction bigger. And g of x is log base 3 of x. And they want us to find g of h of 5. All right, so this guy's first. H of 5, 1 over 5 squared plus 2 gives me 1 over 27. Now I got to drop down g, which is the log base 3 of x. So log base 3 of 27. Now you can do a couple of things with this. First thing, change the base formula, less than 1. Log of 1/27 divided by the log of 3. Log of the power divided by the log of the base. And this is going to give us negative 3. The other thing we can do is take this again from lesson 1. We did these all multiple ways, if you remember. Maybe I was boring you in school. Maybe you're listening to me more now. We could say, okay, what does this equal? And then we could say the base is 3. And remember, the exponent is the log. Exponent is the log. Exponent power. And flip. 3 to the x is equal to 1 over 27. Exponent form. Log form to exponent form. Well, to get 27 in the bottom, 27 is 3 to the third, and in the bottom, x is still negative 3. So when we did these, we always had the answer twice, or the way to do it twice. It was choice 4 for an answer. Number 14, another one with the, going back to lesson 1, the log base b of b to the x. Okay, now this is what I would say to you. The log means an exponent, and here's its base. Here's a base and an exponent. The bases are the same. They cancel. Everything drops out. It equals x. And that would be choice 1. So if you notice on this review sheet, they're kind of wiggling back and forth between really hard and super simple. So these ones brought us back